Welcome dear student to our YouTube channel. In this lecture, we will do practice section on coordination compounds, which will be asked in your upcoming board exam. So, keep the pen and copy and write the question from coordination compound. Coordination compounds. So first question is, what is the oxidation number? That is the oxidation number of nickel in this compound. So the second question is, give IUPAC name. You should try the answer for the first question. I am writing the second question for you. After that, we will discuss the answer for the question with explanation. So give the IUPAC name of the compound Ag NH3 whole 2 OH. So first write the question and try the answer and mention your answer in the comment section. In this case, the first of all you have to know, it is the square bracket here, called as coordination sphere, and the first part of the coordination sphere express the transition metal, that means the d block metal, and the rest versions belongs to ligand section, and the ligand here is CO, which is carbonyl group. And you know, if you have the idea upon ligand, you know it is a neutral ligand. It is a neutral ligand, and neutral ligands has a zero oxidation state, and carbonyl group has zero oxidation state. That's why if you want to find out the oxidation number according to the question, then what will you do? We will put X for the atom whose oxidation number is to be calculated, and now the previous concept of oxidation number will be used. That means the total number of ligand will be multiplied with the charge of the ligand, that means 0, and the total or the sum of the oxidation number will be equalized to the sum of the charge present over the coordination compound, and there is no charge, that means the compound is also neutral. That's why we will equalize the charge of the compound to 0 and the X value becomes 0. That's why the oxidation number of nickel in the given compound is 0. So if you have done correct, you are right. Moving for the second question, what is the IPC name of the compound? So the given compound is AgNH3 whole 2 H, AgNH3 whole 2 OH. So in this case, it is the transition metal, it is the ligand, and the outside part of the coordination sphere, or the second part, I am telling it the first part, it is the second part. The second part of the coordination sphere is for non-metals, and if it contains any part at its left side or first side, it will be always metal. That means the coordination sphere charge It is a coordination sphere, and the coordination sphere charge always depends upon the charge of the non-metal present at the second side or metal present at the first side. That's why what will happen? The charge over the sphere, a coordination sphere, will depend upon the charge of the non-metal, and the non-metal has the charge that it is -1. So the charge over the metal or the coordination sphere will be +1. And you know that during nomenclature, the ligand name with their numerical prefix comes first. After that, the metal name and oxidation number is written, and we finally express the name of the non-metal. That's why two number of ammonia has its prefix, it is amine, and the two ammonia is present. That's why we will use diamine. Amine is the prefix for the ammonia. So the name is diamine. It is not single M, it is double M. Diamine. So diamine, it is silver, and the name is silver. Diamine, silver, and the oxidation number of the metal will be just written after the name of the metal, and the non-metal name will be written by keeping some space, and the non-metal has its name, that is hydroxide. Non-metal has a name, that is hydroxide, and the name for the compound is diamine, silver. And you know that NH3 has a ligand whose oxidation number is 0. So keeping here 0, we will multiply the total number of ligand with the oxidation number, and for silver we will place here X, and for hydroxide we will place here -1, and the charge over the compound is 0. That's why the X value becomes, it is total value is 0, X -1 equal to 0, X will be 1. That's why X becomes 1, and we know that oxidation number is always expressed in Roman digit, and that's why the silver has the oxidation number 1, and it is expressed as capital I, and the name becomes diamine, silver I, hydroxide. So if you have done correct, mention it in the comment section. Moving for the third question. The third question from salt section. So moving for the third question here. The third question is from MCQ section, that is Mohor salt is a which type of salt? Mohor salt is which type of salt? Is which type of salt? The options are simple salt. Second option is double salt. Third option is complex salt, and the fourth one is none of these. You should try first. I am writing fourth question for you. Effective atomic number, or EAN, express which part, which part for complex? The options are stability, when metals have electronic configuration, of their next inert gas, and the second option is no use in stability. Third one is effective atom number express the coordination number. And the fourth one is none of these. So in this section, the Mohr salt along with potash alum and carnallite, these salts belongs to double salt because equimolar combination of simple salts produces double salt, and the simple salts are produced through neutralization of acids and bases, and double salt are produced by the combination of simple salts in equimolar ratio. But the complex salt is a coordination compound in which the dative bond is present. That's why the double salt includes the potash alum, carnallite and Mohr salt. So the correct answer for the question is double salt. Effective atomic number is the number or the value for an atom or the transition metal present inside the coordination compound, whose value express the stability of the transition metal present in the coordination sphere. What we have told, the square bracket, and the metal stability or the stability of the complex. Stability of the complex means coordination compound or complex salt expressed by the effective atomic number, whose value becomes equalized to the atomic number of the inert gas present next to the transition metal present in the coordination compound. That means if we will consider the transition metal from fourth period, that means from cobalt, which is present in the fourth period, then in that period the transition metal which is present is cobalt, and the next inert gas present or the electron number of the inert gas present in that period, that means krypton. That's why effective atomic number express the electronic configuration of their next inert gas present in that period. So it is the correct answer for the question. There is no use for the next options. So if you are done correct, mention it in the comment section. So you write it fast. After that we will go for the next question. Moving for the next question, and the next question is from ligand section. So ligand is the vital part of this chapter. And it is the fifth question for you. C2O4 2 minus is dash dentate ligand. You answer or fill in the blank type question it is. You answer it first. Always remember the ligand with the charge for oxidation number calculation, for the dentancy of ligand, for coordination number calculation. So ligand is a vital part of this chapter. So moving for the second question. Sixth question is here. NO2 is dash type ligand. NO2 is dash type ligand. Or next question is, seventh question is here. Which coordination value, which coordination number value express, which coordination value express octahedral structure, octahedral structure. So the fifth question belongs to the ligand section, and I am just opening this part. C2 means C2, O4, it is O2 here, and O, it is O. It is nothing but this opening part of the structure, that is C2, O4, it is O4. Keeping in mind, by satisfying the valency of the atoms and -2 charge, it is the -1, it is another -1, so it is -2 charge. In this case, the ligand is oxalate ion. The ligand is oxalate ion, and the oxalate ion has its condensed formula C2O4 and you know that it is a bidentate ligand. It is a bidentate ligand, and the dentency of the ligand is 2. You can also write it as like this: COO, COO minus minus, and the dentency of the ligands, will be 2, and so it will be called as a bidentate ligand, and C2O4 is a bidentate ligand which is oxalate ion. NO2 is which type of ligand? In NO2 it is a ambidentate ligand. Ambidentate ligand. Why it is a ambidentate ligand? Because ambidentate ligand is that type of ligand, mark this marker, when it is a ligand and it has 2 donating sites, and if a ligand has more than 1 donating site and at a time it donates lone pair of electron from a single donating site, at that time the ligand is termed as a ambidentate ligand. That means in NO2, nitrogen is one donor atom and oxygen is another type of donor atom. If NO2 donates lone pair from nitrogen at a single time or oxygen at a single time, at that time it is termed as ambidentate ligand, or you can define it as that when a polydentate ligand donate lone pair of electron from a single donating site, at that time the polydentate ligand will be termed as a ambidentate ligand. That means ambidentate ligand is from polydentate ligand, but the specific feature is ambidentate ligand donates lone pair of electron from a single donating site at a time. Moving for the 7th question, which coordination number value express octahedral structure? You know that the coordination number value 2 express linear structure, coordination number value 4 express tetrahedral structure or square planar structure also. Similarly, the octahedral structure is expressed by the coordination number value 6. So the complex or the coordination number, a coordination compound having the coordination compound having coordination number 6 express the octahedral structure. In the coming class, we will practice more questions from this section. If you like the video, share the video with your friends. Thank you.